Hi everyone. So today we're going to talk about solar and lunar eclipses. So let's get started. In this simulation, let's make it full screen. You see the sun right here, the earth is here, and the moon revolving around the earth. Now, as the moon revolves around the earth, what it does sometimes is it creates a blocking effect from our point of view. It sometimes blocks the sun from our point of view. And then as the moon keeps on revolving around the earth, sometimes the moon itself is blocked from our point of view because we're blocking the moon from the sun. So let's see what that looks like. So in the bottom, you'll see how the moon looks like from Earth as it revolves around the Earth, and it also shows what the sun looks like from Earth as the moon revolves around the Earth. Um, so, and I also want to show you where the shadows are for the moon and the earth as the moon revolves. So let's see what happens. So the moon is revolving around the earth. Let me just show you what it looks like. If I speed it up, this is how the moon revolves around the earth. And as it does, notice that it's creating some shadows, not only on the sun, but on the moon as well. If I slow this down, watch what happens. The moon is revolving around the earth. We're seeing the moon phases as we've talked about before, and it looks like the moon is getting closer to the side of the sun. So we're getting close to a new moon. And so that means it's waning or getting darker on the right side from our point of view. So it's starting to get darker until it's a new moon, right? Right here. So it's a new moon, yes. But notice what's happening to the sun over right here. So notice that as the moon is starting to get aligned between the sun and the earth, the sun over here starts to slowly get blocked from our point of view by the moon until it gets completely blocked by the moon. And it looks something like this. This is called a total solar eclipse. Solar eclipse because the sun is being blocked by the moon from our point of view. Solar means sun, eclipse means the blocking or darkening of one celestial object by another celestial object. So in this case, the sun is being darkened or blocked by the moon, and that's why it looks like this for us. Now, we can also have a partial eclipse that kind of looks like this, where the moon partially blocks the sun from our point of view. So this is what a solar eclipse is. When we talk about a solar eclipse, the sun, solar, is being blocked or darkened by the moon in this case. Now, notice that as the moon keeps on going around the earth, on this side we normally have a full moon, right? And I'll talk about why this is not the case every single time. This is actually a rare case of what I'm showing you. So when the moon is here, it's very normal for us to see a new moon only because we're seeing the darker side of the moon, but this phenomenon of the moon darkening or blocking the sun is actually pretty rare. And so is this thing over here where the moon goes around to the other side of the earth. Normally, as we've talked about before, the moon is a full moon on this side, right? Because the sun, we're seeing the side of the moon that is lit up by the sun. But notice what's happening in this simulation. The moon is starting to get darkened because it's falling into the Earth's shadow. So notice that this time sun is not being blocked or darkened, the moon itself is, and the moon is being darkened or blocked because the earth is now blocking the moon from even experiencing much sunlight from the sun. And this is what we call a lunar eclipse, meaning the moon, lunar means moon, lunar eclipse because the moon is being darkened or blocked this time by the earth. So when the one celestial object is being blocked or darkened, we use that name for that object to call it an eclipse. So solar eclipse when the sun is being blocked, and lunar eclipse when the moon is being blocked. And please remember the positions of the moon. So this is the position of the moon when we have a solar eclipse, and this is the position of the moon when we have a lunar eclipse when the earth is blocking the sunlight. Okay. Um and yeah, let's take a closer look over here. So let's talk about some vocabulary. Eclipse is the darkening or blocking of a celestial object by another, as we've seen. And a solar eclipse is the darkening or blocking of the sun. A lunar eclipse is the darkening or blocking of the moon. So the two types of eclipses are lunar eclipses and solar eclipses. A lunar eclipse is when the moon is being darkened or blocked by the earth, and the solar eclipse is when the sun is being darkened or blocked by the moon. Have your notepad out and let's write this down. So we have two types of eclipses. One is solar eclipse. Notice the moon's position in a solar eclipse, where the moon is blocking the sun from our point of view, and that causes the sun to appear to be darkened by the moon. And then in a lunar eclipse, which is the other type, the moon is now in the shadow of the earth, and the moon is being darkened or blocked by the earth. That's what we call a lunar eclipse. Let's talk about the shadows a bit more, and let's take a closer look at the solar eclipse. So we said in a solar eclipse, the moon is blocking the sun from our point of view, and that's why the sun looks dark, right? The sun looks like it's being blocked. Let's talk about the shadows, though. When the sun moon is in this position and the moon is blocking the sunlight from reaching Earth, notice that the moon creates two types of shadows on Earth. Remember, shadows fall on the opposite direction of where the sun is. So if the sun is on this side, the shadow will follow to this way, right? So there's a darker part of the moon's shadow called the umbra, and then there's a lighter part of the moon's shadow called the penumbra. And there's a lighter part because in these lighter areas there's a little bit of sunlight peeking through, but in the darker parts there's zero sunlight. So for us on Earth, if you're in a location where you're in the umbra of the moon, the darker part, then from your point of view, you'll see a total solar eclipse. The sun will look completely blocked by the moon. The sky will become dark for a little bit. But if you're in the penumbra, this lighter part of the moon's shadow, where there's still little bit of sunlight coming in, the angle at which you're seeing a solar eclipse will look like it's partial, where the moon is slightly blocking the sun but not completely blocking the sun. So it really depends on the location you're in, whether you're in the moon's umbra of the shadow or the penumbra. Let's talk about lunar eclipse. Remember, lunar eclipse is when the moon is on this side of the Earth, away from the sun. And because when the moon is on this side, the Earth is now blocking the sunlight from reaching the moon, and also the Earth is casting its own shadow on the moon. And this one's interesting because when this happens, there's still a little bit of sunlight peeking through, and because it does that and it interacts with our atmosphere before reaching the moon, that sunlight gets refracted, meaning bent a little bit to reach the moon. And that causes a color distortion the way we see the moon. And the moon kind of looks red because the light is being refracted or bent a little bit as it passes through by the earth from the sun to the moon. So we call this a blood moon, and this is very rare. Other things that can happen is a partial lunar eclipse where the moon is not completely blocked by the earth, but almost. But you can also get a penumbral lunar eclipse where the moon is not completely in the Earth's umbra to get a total lunar eclipse, but in the penumbra, the partial shadow of the Earth. And this makes the moon slightly darker. You can still see the moon in all these cases, but either the moon gets slightly dark if it's in the penumbra, or very dark when it's in the umbra. And a lot of times when the moon is in the umbra completely, it looks reddish like a blood moon. Now, why is this rare? I said this is rare, right? Solar eclipses or total solar eclipses don't happen often, and total lunar eclipses don't happen often, although partial solar and lunar eclipses are pretty common. So, why are total eclipses very rare? Well, the moon's orbit is not the same as the Earth's orbit. We know that the Earth revolves around the sun, right? But the moon revolves around the Earth. So when the Earth revolves around the sun, the plane at which the Earth revolves around the sun kind of looks like this. This is the Earth's, it's called the ecliptic plane. This is the plane in which the Earth is going around the sun. Okay. But the moon is different because the moon's plane of orbit, the way it orbits the Earth, is inclined by another 5 degrees. It's tilted by 5 degrees compared to the Earth. So it's kind of like this. And the moon is actually kind of going around the Earth in the tilted way, 5 degrees tilted. Okay. And the thing is, not only is the moon's orbit slightly tilted by 5 degrees from the Earth's orbital plane, but it moves kind of like this. It wobbles. Do you see this? So not only is it tilted from the Earth's orbital plane, but it's going up and down, and the orbit is wobbling. And because of this, the moon is sometimes higher than the sun and the Earth's plane, and then lower than the sun and the Earth's orbital plane. And it's very rare for the moon to be in complete alignment right about here, right between the sun and the Earth, to cause a total solar eclipse, kind of like this. Okay. But most of the time, it kind of looks something like this, where the moon is sometimes higher than the earth and sun, sometimes lower, and very rarely will it appear right on the orbital plane of the earth and the sun to completely block it. So all you need to know that is that the moon's orbital plane is around 5 degrees tilted from the earth's orbital plane. Okay. So go ahead and try the questions. That's about it. Thank you.